So looking at integration by parts, like again, all integration is just anti-differentiation. So we're reversing our process. So here the reversal is of the product rule. And if you remember your product rule, so the derivative of two functions, derive one function, multiply the other, and then reverse that around. If we start with that product rule and reverse it, we take the integration of each function, and this is where we start to get this statement that we've seen. So the way you remember it, it's up to you. I remember it differently to Alan, and the way I've taught it before is different than that. I just consider two functions being integrated there, and I call one a first function, the other one a second function. And so my work I do with it is to integrate the first function and leave the second function. So I start with a derivative. So that's where the idea of I start with a derivative and then that gets integrated and the second function gets left. And then I've got minus the integral of integrating the first and deriving the second. So that's how I really remember it in words, and that's how I start to apply it rather than all the complicated notation that we start to see. A lot of times, and that's how I teach it. I teach it to the kids in using just words and thinking about what the concept's happening with the functions themselves. Now, the trick is, which one do I take as my first function, which one do I take as my second? So you've got to keep thinking about exponential functions and cosine and trig functions here, that they never differentiate and to zero. So that's the big key, where if I'm looking at this one and deciding which one I'm going to differentiate and which one I'm going to integrate, I'm going to look at the x and go, well, if I differentiate that one, eventually that will become a constant one. So my function will start to simplify. So that's the one I start looking and go, okay, this is my first function, because that's the one I'm going to integrate, and I'm going to treat this as my second function, which is I'm going to leave. So I integrate my first, so cos integrates to sine, leave my second, and then integrate my first and multiply by the derivative of the second. Now you can see that the x cos x now gets simplified, and the second derivative I've got to do here is just the integral of sine x, which is that's just a simple function. So we get x sine x minus integral of sine x, which is minus cos x, which becomes x sine x plus cos x. So that's how I go about doing it. I know Alan uses some notation and things like that. I tend not to use that and just think, well, which one's going to be the simplest one to differentiate? And it's usually not an exponential, it's usually not a trig function. So that's what you've got to look at to simplify. So if this one, x squared ex, well, as soon as I see the x squared, I'm going to have to integrate by parts twice. That's a first world problem. So we get x squared ex. So I've integrated the first. I've treated ex as the first, e to the power of x as the first, and I've left the second of x squared, and then I've integrated the e dx, and I've derived x squared, which gave me 2x. But then again, you see, well, I've still got the same problem. I've got to integrate by parts again. So e dx is going to be my first function, and 2x is going to be my second function. So I integrate the first, leave the second, integrate the first, derive the second, and then I can integrate to e to the x, which is really nice. Just be careful about the negative that's out the front there, so I've put the parentheses around that way. Now, I want to finish with the idea we said before, we couldn't integrate log of x because we don't have rules. Unless you want to remember that that's the actual rule that you get. So what we go and do about this one, well, again, I can't integrate log of x, so I can't take that as the function I'm going to integrate first and leave the second. And what I do a little trick, and I say, well, I treat that as 1 times log of x, and treat 1 as my first function and log as my second function. So I integrate my first, which just becomes x, and I leave my second. I integrate my first function again, which is 1, which integrates to x, and I derive natural log, which I can do. So that was really the only option that was left for me. And this really actually works nice because the x's cancel. I get 1, so that's all I've got to integrate to get to the x there, and just change that because that should be a minus x there. So change that on the notes if you download them. Okay, so that's what integration by parts looks at. Again, have a practice with some of them and just play around with picking your first and your second. And sometimes you get some functions in there that you can't integrate. So like a log or inverse trigonometry, well, that's you can't integrate those ones without doing integration by parts. So they're the ones you're not going to integrate. You're going to look to derive those ones.